All right, what is going on, everybody? We are coming at you live from the quarantine studio in Mr. K's house. Today, we are starting chapter 11. This year is going by so fast. I feel like just yesterday we were going into quarantine, and now we are already in chapter 11. Chapter 11 is talking all about area. We've seen area, we've seen perimeter. In previous chapters, we've used them a lot, but today we're going to give a little bit formal definition, and we're going to learn some formulas that go along with area. To get started, we're going to talk about area. Go figure. So, we're going to give a formal definition to area, and that is, area is the amount of space in a two-dimensional 2D figure. The amount of space in a 2D figure. Area is denoted by a capital A. It's denoted by a capital A, and when we talk about area, we're going to be talking about units squared, or units squared like that. Next, we're going to give a formal definition to perimeter. I know we've talked about perimeter in the past, so we won't spend too much time on it, but we do want to give a formal definition to perimeter. That being that perimeter is the sum of the side lengths of a polygon. The sum of the side lengths of a polygon. Perimeter is denoted by a capital P. Right, like that. We're going to see perimeter. We're going to use perimeter. But for now, we're just going to talk about area. And to do so, we're going to learn some formulas for area. Today, we're only going to learn two formulas for area. Going to learn two formulas that are closely related. First one being the area formula for a square and for a rectangle. Now, if we remember, a square is a rectangle, but a rectangle is not a square. The formula for the area of a square is going to be A equal to S squared, where S is our side length. In a square, we know all the sides are equal, so we only need to know the length of one side. If we know the length of one side, we know the length of all the sides. We know that area is, if we take our sides, take our base times our height, or our length times our width. In this case, we know our base is equal to our height, our length is equal to our width. So we just use one letter, S, for our side length. We square it, we get the area. Now, for a rectangle, we have A is equal to length times width, or A is equal to base times height. Now, I like to use length times width because I get to do that sweet L right there. I really like that L. So I like to use length times width when talking about a rectangle, but if you like base times height, you do you. You choose, it's your life. There we go. Couple of formulas, and we're gonna get to see them in action right now with a couple of examples. So here we go. Let's see if I can do this. There are formulas, and here is our first example. First example says a square has a perimeter of 44 inches. What is the area? I don't know what the area is, but we're going to find out what the area is. So if we have a perimeter of 44 inches, if you miss the fact that this is a square, if you read too quickly and skip over that it's a square, you might start thinking, well, what is the perimeter of 44 inches? How can I use that? But if we know it's a square, we know all the sides are congruent. We know they're all equal in length. And if we have a total perimeter of 44 inches, we know a square has 4 sides. We take our 44, we divide it by 4, and we get our side length is equal to 11 inches. From there, we can plug that right on into our area formula up here for squares. So we get area is equal to 11 squared, which is equal to 121 inches squared. We don't want to leave off that squared when we're talking about our area. We don't want to leave that off. We always want to say area inches or units squared. In this case, like I said, inches squared. There we go. First example for the day. Now, we're going to move on to another example. This one's a little bit trickier. Now we're talking about a rectangle. We have a rectangle that has a length of 8 and a diagonal of 10. We want to find what the area is. So we're going to be using our rectangle formula up here. But since we know that its length is 8 and its diagonal is 10, we can't do a whole lot with that. We're going to learn about triangles a little bit later, maybe in a couple of days. But for right now, we don't know that formula. So we're going to try and use our rectangle formula. And to do this, I'm going to draw a picture. Might help you out to draw a picture as well. We have our beautiful picture right there. And I'm gonna make this bottom side 8. I'm gonna make this our length. I'm gonna make that as 8. And we have our diagonal right here. And we know that that is 10. Now we just got done with a unit on right triangles. As you know, geometry is all right triangles. And we learned about some special right triangles. Now to me, 8 and 10 doesn't necessarily look like any one of our special right triangles. Or does it? Because if I take 8 and 10, I know they're both even numbers, so I know I can at least divide them by 2. So what happens when we divide these by 2? Well, we get 4 here, we get 5 here. And if we have 4 and we have 5, we have one of our legs is 4 and our hypotenuse is 5. Well, that sounds like a 3, 4, 5 triangle. And you would be correct. Now, that doesn't mean that this side is 3. Because if we put 3 there, it would be wrong. But we multiplied these two, our 8 and our 10 by 2, or divided them by 2. So we have to multiply our 3 by 2, and we get our final side is 6. With that information, we use our area formula up here for rectangle. So area equals length is 8. And our width is 6. 8 times 6, which is equal to 48 units squared. We weren't given units, but we're going to write units squared anyways. There it is. This one takes a little bit more work, which is good because our last example takes a lot of work. Here it is, our last example for the day. Bum, ba-da-bum. Boom. Man, this looks crazy. But we're going to dive right into it. So we want to find the area of the figure. To do so, we have a lot going on. I didn't give you the formula to find whatever this is. But what I did give you is the area to find squares and to find rectangles. So what we're going to do is we're going to break this figure up into what we know, which is squares and rectangles. Now, there's a couple of ways that I'm going to do it, or that you could do it. If you want to try this on your own, go ahead and pause the video and try it on your own. If not, you can go right ahead and keep moving with me. The way that I'm going to do it is I'm going to extend this line right here up and down. I'm going to extend it up and down. What I mean by that is I'm going to take this and I'm going to extend it up and I'm going to extend it down. Because what that does now is this. I'm going to look down here because I know that this side right here is the same length as this right here. So I know this is 3. I know that side length is 3 right there. So if I wanted to, I could go ahead and solve that area right there. I'm going to wait until the end. I'm going to find as many measurements as I need, and then I'm going to go back and find the area of all my individual rectangles. Because right now we have 3 rectangles. We broke it up into 3 rectangles. So I have my 3 here. I know this whole side length over here is 8. So I know this whole side over here, the whole length of this line segment should be 8 as well. If I have 3 and I have 2, that's 5. So the only thing that's left is 3 right there. Now I'm not done yet because I can find the area of this rectangle and I can find the area of this rectangle, but I can't find the area of this rectangle. Not yet. But something that I know is this side right here is 5. But this whole side up here is 10. And this whole side here should equal 10 as well. If I've used 5, half of 10, this little section right here should be 5 as well. Now we can go ahead and solve for the areas of these rectangles. I'm just going to go top to bottom. And what I'm going to do is I'm going to label this as area 1, little subscript 1. And you'll see why towards the end here. But I'm going to label that as area 1, area of my first rectangle that I'm solving for. And if I use my area formula up here, let's move it down a little bit. There we go. Now we got it. If I use that, we have length times width. We have 3 times 5, which is going to be 15. Don't forget our units, squared. Then I'm going to move over to this long one over here. I'm going to label that as area subscript 2. And that's going to be 8 times 5. And that's going to be 40 units squared. And our last one down here, I'm going to label this as A subscript 3. And that's going to be 3 times 1, which is 3 units squared. Now that we have all of our rectangles, what we're going to do is we're going to find the area of the total figure. In this case, the area of our total figure is all of our other areas added up. Our A1 plus our A2 plus our A3, our area of 1, 2, and 3. When we do that, we're going to have that be 15 plus 40 plus 3, which is going to give us a total of 58 units squared. And there we have it. So that's it for the notes for today. We have a worksheet that you can go ahead and work on, as well as office hours if you need any help. Or you can send us an email, or a chat on Schoology. Go ahead and get working on that, and we will see you tomorrow.